Imagine a world with no power plants, no fuel shortages, and no dead phone batteries. Picture a machine in your home that powers everything, forever, without ever needing a recharge. This is the dream of perpetual motion, a device that runs endlessly without any external energy. For centuries, inventors have chased this idea, hoping to create limitless, free energy. The appeal is obvious. Energy is everything. It powers our lives and shapes our history. A machine that generates its own power would mean ultimate freedom from resource limits, but dreams that sound too good to be true usually are. The idea of a machine that runs forever bumps up against the fundamental laws of the universe. To understand why, we need to look at the science behind energy. Science explains why some things work, and why some things, no matter how beautiful, just don't. The perpetual motion machine is one of those beautiful, impossible dreams. Let's see why. Perpetual motion machines come in two impossible flavors. The first kind claims to create energy from nothing, like magic but for physics. The second kind promises perfect efficiency, recycling energy forever with zero loss. The first kind would be an energy factory, producing power from nowhere. The second kind seems more reasonable. It just reuses energy perfectly, like a ball that bounces forever without losing height. But both ideas break the rules of physics. The first kind tries to make something from nothing, a get-rich-quick scheme for energy. The second kind ignores the little losses that always creep in: friction, heat, and resistance. Even the cleverest designs can't escape these invisible thieves. In the real world, energy always leaks away, and perfect cycles are impossible. That's why perpetual motion, in any form, remains out of reach. But what are these rules it breaks? The laws of thermodynamics are the universe's rulebook. The first law says energy can't be created or destroyed, only changed. Every bit of energy must come from somewhere. You can't get more out than you put in. That's why a perpetual motion machine of the first kind is impossible. The second law introduces entropy, a measure of disorder. Every energy transfer loses some energy as waste heat or friction. No process is 100% efficient. There's always a tax. Think of a bouncing ball. It never bounces back to its original height because energy escapes as sound and heat. Every real machine faces friction and resistance, slowly grinding to a halt. These losses are unavoidable, no matter how clever the design. That's why perpetual motion, of the second kind, is also impossible. The universe simply doesn't allow free energy or perfect efficiency. These laws have never been broken, and they're why perpetual motion remains a fantasy. History is full of failed perpetual motion machines. The overbalanced wheel, with weights or balls meant to keep it spinning, never works. The forces always balance out, and it stops. Magnetic machines are another favorite, but magnets can't do work for free. You always have to put energy in to get energy out. No matter how clever or complex, every design eventually grinds to a halt. The universe's rules always win. These failures are reminders that even the most creative ideas can't break the laws of physics. What about the Earth spinning or planets orbiting the sun? Isn't that perpetual motion? Not quite. In space, there's almost no friction, so things can coast for billions of years. But even they slow down, bit by bit. They aren't creating energy, they're just using momentum from the past. A true perpetual motion machine would break the laws of thermodynamics, rules as fundamental as gravity. These laws govern everything, from stars to engines, to our own bodies. If someone claims to have built a free energy device, be skeptical. Science thrives on new ideas, but it also respects the universe's limits. The dream of something for nothing is powerful, but reality, with its rules, is where real discovery happens. Keep questioning, keep exploring, but always remember the universe plays by its own rules. And that's what makes science both challenging and endlessly fascinating.